All right, this is a 6.1 online help session. This particular problem says for each year the population forest of trees called forest A is represented by the function 113 times 1.024. In a neighboring forest, let's call it forest B, the population of the same type of tree is represented by 84 times 1.027 t, or raised to t. Which populations, which forest population is growing faster at a faster rate? Well, if we look at this, this is A times B raised to the t, right? So our base for A, let's look at A. Our base for forest A, we call it trees A. How about that? Tree A. Our base is 1.024, right? So our base is equal, but it's a growth, right? It's a growth because it's greater than 1, right? Okay. Our base is greater than 1, so therefore it's growing. But in order to get the base really is 1 minus r, or I should say 1 plus r. So if I go 1.024 equals 1 plus r minus 1, so we have a rate of 0.024, which is at 2.4%, right? Okay, so we're going to say trees A, tree A is at a growth rate of 2.4%, and then we'll look at trees B, tree B. I'm going to show you this both ways. We'll erase this right here and do it again. Tree B is 1.027. The base equals 1 plus r. So 1.027 equals 1 plus r. So minus 1. 0.027 equals r, which equals 2.7%, right? So 2.7% is how fast the rate is for tree B. Now, we could, that's mathematically doing it, right? Okay, base can be equal to, let me see, base can be equal to 1 minus r, or base could be equal to 1 plus r. This is for growth, and this is for decay. Okay, so the base represents. Now, if you'll look at, here's the base here, right? 1.024 and 1.027. Who's the biggest? The biggest base is 1.027. So which population is growing at the faster rate? Well, it would be tree B, right? Or forest B. Does that make sense? Now, which forest had initial greatest number of initial trees? Well, A, right here in the A times B raised to t, A is the initial amount. So if we look at this, and let me go here, and I got 113 for A, and I got 84 for B, for forest B. 113 in forest A, 84 initial trees in forest B. Who has the greatest number of trees in the initial beginning? A. 113 of them, right? See that? Forest B only had 84 to begin with. That's what that A here is telling you. By how many trees? Well, 113 minus, if I'm right correctly, 113 minus 84. And if I do that, 113 minus 84, that is 29 trees. Okay. Now, any questions up to there? Okay. You got to make sure, like exponential is written in the form of a times b raised to the t, and the b is the base, and the a is the initial value. So if we look at this in Forest A, 113 is the initial value with a base of 1.024, right? And then Forest B had an initial amount of 84 trees, but with a base of 1.027. All right. Now, let's look at part C. Assuming that the population growth model continues to represent the growth of the forest, which forest will have the greatest number of trees after 25 years? Well, all we're going to do is, yeah, we're going to plug in 25 there, and then we'll go 84 times 1.027 times 25 there. Okay. So let's see, 113 times 1.024 raised to the 25. I got 204. Sit round to the nearest tree. I got 204.4, which is equal to 204, right? And then the second was 84 times 1.027 raised to 25. And I got 163.5, which is approximately equal to 164, right? So that should tell you that, assuming that the growth models represent the growth of a forest, which forest has a greater number of trees after 25? Well, Forest A, right? Okay. And by how many? 204 minus 164. That would be 40, right? 40 trees. 204 minus 164. Yep, 40. So that's what they're doing there. All right. So, what's the other one? You got any more? This is a good one. It says write the equation. Now, I do this on the video, but it's definitely one that you'll see. Could possibly see on a final exam. You could possibly see on the test coming up. So let's kind of make sure you're good on this, okay? Now we've got to do y equals a times b raised to t, right? Well, you always, the way that I teach it is you always put the second one, the biggest one over the smallest one. Okay. Or the second one over the first one. Here's the second one over the first one. Because it's, I shouldn't say the biggest one over the smallest one, the second one over the previous one, and because it's exponential, to tell you whether things are growth or decay. So you got X and Y's, right? So what we're going to do is we're going to say, okay, here's 45. That is the Y for this one, right? Okay. Now, we don't know what its A is. We definitely don't know what its B is. But we do know that it's to the second power, right? Because I put a T, it should have been an X, right? Okay. All right, now let's do it again, but now we're going to use this second. So 5 equals A times B raised to the 0. Okay, and what you're going to do is you're going to divide. Now, 45 divided by 5 is nothing more than 9. The A's cancel out, right? Leaves me with B's, right? And if you remember properties of exponents, when you have the like bases that are being divided, you subtract them. So really that becomes 2 minus 0, which gives me 9 equals B squared, right? So we take the square root of both sides. The base is equal to 3. Okay, so now we have the base. All we have to do now is find the A, the initial value, right? So we start right back over. We could pick either one of these points, right? We could do 2 and 45 or 0 and 5, doesn't really matter. For grins and giggles, I'll do 2 and 45. So I'll go 45 is the Y, A times 3 squared. Okay. Now, that's going to give me 45 equals A times 3 squared. Well, 3 squared is 9, right? So that should give me 9A. And I'll turn around and divide by 9. So I will get 5 equal to A. So my equation will be 5 times 3 raised to the X. That's the equation from these 2 points. Okay. So it's kind of a two-parter. When you're doing exponential, if you remember geometric, excuse me, if you remember geometric sequences and stuff like that, you always go the preceding one divided by the previous one to see what its constant multiplier or constant ratio is. That's why I put the second up top and the first one on the bottom and divide, right? So that allowed me to, my A's canceled out, allowed me to solve for B, right? And the thing about this, your B's could be, it could be raised to a power of 2, 3, or 4, right? But the number over on the left-hand side should either be, if it's a 2, it should be a perfect square. If it's 3, it should be a perfect cubed. If it's 4, it's a perfect fourth root. So just kind of remember that. Now, I chose the second value or second set of order pairs to be able to find my A, right? I did that to, it doesn't matter, but I did that because when my initial value is when X equals 0, my Y is the initial value, right? Look right here. have an x equal to 0. What's my initial value? Look what we got. So if your x is 0, that means you're setting on the y-axis, right? That's your initial amount at time 0. So I could have went, okay, once I found my b, okay, hey, I got x is 0, got y is 5, it's 5 times 3 raised to the x, right? But I wanted to take that opportunity to give you an opportunity to solve for a. All right. All right, let's look at another one. 8 works just like that, but 8 doesn't give you a 0 in x, right? Yeah, it works the same as what we just worked. Trying to think if there's another one that you might run into that's crazy. No, that's okay. All right, let's look at this one. This is number 11, right? Um, I was going to take a picture. All right, there it goes. Took the whole thing, so go here and go. All right. So if we look at this, for an exponential, account contains $1,434.73 and has been accumulating interest at 8% annual rate, compounded continuously for 5 years. Find the initial deposit. Well, it's A equals PERT. A equals principal times E raised to RT. E is an exponential function, right? E is a special exponential function. It's geez, I just said 2.71828. 2.71828 dot 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 dot. It's kind of like pi. It goes on forever, right? So instead of saying using that and having to round off and everything, we just made it E. Everything in nature multiplies or expands exponentially by E, right? You look at the virus, the COVID-19 virus. If you were to look at the rate of it's probably approaching E, which is the fastest growth, which is continuous, right? All right, so A is the final amount, P is the initial deposit, R is the interest rate. Write that a little bit better. That is as a decimal, right? It's got to be as a decimal. And T is time in years. Okay. So if we're looking at this, let's see. Hmm. What link did you use for the help session? Was it the one that I sent out, or is it the one you up on Blackboard? Oh, it is? Ooh, it's wrong, isn't it? Okay, hold up. I grabbed the wrong one, didn't I? Alright, so turn this back on. Alright, okay, so alright, so let's look and see what we've got. We've got an account now contains $1,434.73. It's been accumulating 8% interest annually, compounded continuously. That means it's going to be an E, right, for 5 years. Find the initial deposit, right? So 1434.73 equals P. E to the rate is 0.08 times 5. And what we're going to do is we're going to divide by this cancels. So when I do this, what I want to do is 1434.73 divided by open parentheses E to the 0.08 times 5, and then close parentheses, and I got $961.73 equals P. How did you do? Yeah, you got to divide, okay? Yeah, 0.73. What'd you get? Me. All right. Okay. All right. Um, let's see. Make that go away there. All right. Um, Let's see. They got on like 20. Yeah, that's continuous and everything. We need to do one that's uh, compounding. There we go. Yeah. All right. So this particular one is number 24, I think. No, number 19. And it's not compounded continuously. It's compounded um, monthly, quarterly, something other than continuous. And when they do that, here's the equation. Okay, A and P's the initial amount, that's the principal. A's the final amount, right? R is the interest rate, but and T is time in years, right? The N is a number of compounding. So N is 12 if it is monthly. Okay. Um, N is 4 if it is quarterly. There's 4 quarters. N is 52 if it is weekly. N is 365 if it is daily. Okay, so what we want to do is this. Find how much will she have to pay if her bill was $1,500 at 23% interest compounded monthly, right? And she intends to pay it in 1 year, correct? So if we look over here, we go A is, I don't know, P is, well, she's borrowing $1,500. The rate is 23%, which is 0.23. T is 1 year, right? So N is 12 because it's monthly. So A equals 1,500, 1 plus 0.23 divided by 12. Now this is 12 times 1, right? Okay. Now what we're going to end up doing is this. We're going ahead and rewriting it again. 1 plus 0.23 divided by 12 over 12 raised to 12. Now, in order to do this, you can type it all in just the way it looks and you can get it, but I tend to do this, okay? I do 0.23 divided by 12 and I hit enter. Then I hit add 1, enter. And then I raise it to the 12th power and I hit enter. Then I times it by $1,500 and hit enter. So that one bill is going to cost us $1,883.80. So, and credit cards charge interest rate, annual APR about 20 to 22%. And they compound it monthly. Um, so, if it takes her 1 year to pay it back, she will have had to pay, instead of the original $1,500 it cost her, she's gonna have to pay additional $383.80. Okay, and that, that is Yep. Raise it to the 12th power. Nope. Times. See this? Times it to 1500. Yeah. That's it. That's it. This is the answer right here. 1883.80. And it came out to be 79.795. 79 and a half cents. So that's 79 and a half. Half, excuse me, made that 79 going up to an 80 cents, right? Okay. So, um, okay. Let's look and see if there's any more. 20 is just doing both of those, right? Comparing between those. Got to make sure you understand that. 16 maybe. Oh, what about it? No, it's just chug and plug. They tell you that in 1960, Coca-Cola was 10 cents, right? A Coke was. And then they say the formula, the cost of formula for Coke is 10 cents times E raised to the 0.0575, I think, right? Times T. But what they're doing is T is the number of years in 1960, so T equals 0 at 1960. Okay, so they want to know what is the expected cost of Coke in 1975. Well, that would be where T is 15, right? 2000 would be T is what? 40. Um, this would be 65, and that would be 75, right? And then round it to the nearest cent. So yes, it is kind of like a chug and plug. But the key thing is you're resetting the clock from 1960. You wouldn't plug in 1975, you wouldn't plug in 2000, you wouldn't plug in 225 or 2035. You would plug in 15, 40, 65, and 75. The reason being is T right here is the number of years since 1970. See, they 1970, 1960, they reset the clock at 1960. That's what they're saying. Your time, yeah, your time is starting from 1960. So you take all your dates minus 1960 to find your T. And then you just evaluate it. So I'm just curious. What does it say? I'm going to do the 2025, which is 65 years, right? So let's see, 0.1. Let's see how close it is. I got to read this. 0.0576 times 65. They say it ought to be $4.23. That's what it says. But does that make sense? No. Right? Um, so now, are they talking about a 12 pack? or they just talk about one little Coke, you know. Well, you think about this now. 10 cents in 1960, right? It's $1.85 now, right? 1.95, yeah. Could be higher, depending on how much the convenience store adds to it for their profit, you know. So, yeah. So what I need for you to do is to kind of go through this. There's um, 20 questions, um, and it's talking about exponentials. You need to. I know you said you watched the video and you're just now starting to work the homework. We have one more help session for y'all tomorrow at 5 o'clock. I fixed that link. The link that I sent out on the email was correct. The link that I grabbed and put up in Blackboard was another help session, but I fixed it. And I'm going to go back and double check it just to make sure. But I'll get it, make sure it's right, um, and everything. But I need you to focus on this, making sure you can look at these and can do these, um, and everything. So that's the goal. Yes, ma'am. No. Um, we have went through it, and let me go back to it. Let me show you number 7. Here it is. So let me kind of show you. Let me block some of this stuff out so that it doesn't. So what I did was, when you're going to have to be able to write an exponential equation, give them 2 points. Okay, and you always take the uh, I call second one divided by the first one, um, or this one divided by the previous one. So there's an x and a y, right, on both of these ordered pairs. So the equation is y equals a times b raised to the x. And what I did was the first 2 and 45, 45 is y equals a times b raised to the x, and x was 2. And then for the second point, or the preceding point, uh, previous one was 0, 5. So 5 was the y equaled a times b raised to 0. Well, your a's cancel out. And if you remember back in exponentials, the properties of exponentials where you have quotients, um, when you divide in like bases, you subtract their exponents. So b is 2 minus 0. 2 minus 0. And what that gave me was 9 equal to b squared. And if I took the square root of both sides, I came out to be the base. Yeah, the base is 3, right? So that part of it's um, pretty standard. Now, here's the a. We have to find the a, okay? So what I did was right over here. Let me make this go down. There. I use this. Y equals a times b to the raised to the x. We're trying to find a. So what I did was I just grabbed the second point. It didn't matter which one of the points that I grabbed, but I grabbed the second one on this one just as a teaching one. Y was 45 equals a times 3 squared, right? Because the x was 2. So what that gave me was 9a equals 45. Divide both sides by 9, a equals 5, right? Now that I know what a is, I know what b is, I can write the equation. And that's what I did right here. Now, I want to point out one thing. anytime you have x as 0, the y value is the initial value. Because if you think about it, when x is 0, nothing has started. That is in the beginning. So its initial value, see, we got x is 0, 5 was y. Guess what we got the initial value to come out to be? 5. So I wanted to use that other point to show you that, but I also wanted you to say, okay, do I have an x is 0? If I do, then I know what my a is, right? So it can simplify a little bit easier than that. And the rest of them are just like that. Okay. Mr. Cole, you good on this one? Okay. Yes, ma'am. Yes, ma'am. 5 to, yes, ma'am. Yes, ma'am. Um, let me get here. Um, which one is it? Okay. Now, okay, if you can, an exponential can grow and an exponential can decay, right? And I'm going to show y'all a little bit of stuff here on using Desmos real quick that I point out on my notes, the graphs of them and stuff. But I want to kind of show you some stuff. Um, so remind me after I get done writing, doing this problem. A car was valued at 32,000 in the year 2009. By 2013, the car value had depreciated to 16,000. If the car's value continues to drop by the same percentage, what will it be worth in 2018? All right, so what we're going to do is we're going to find the base, right? And the base is this: new over old raised to the 1 over elapsed time. Okay, so the new, in the beginning it was 32,000, right? But now the new value now is 16,000, right? So 16,000 divided by 32,000 raised, yes ma'am, new is on, yes ma'am, yes ma'am. They're going to give you, what they're going to give you is a date and a value and another date and a value. So your latest data point would be your newest one, right? Like the 2013 would be a lot newer than the 2009 data point, right? So um, now, how many years is there between 2013 and 2009? Yeah, so 1 over 4. You have to have the 1, right, over elapsed time. Now, that's going to be your base. So we're going to go parentheses 16,000 divided by 32,000 raised to the parentheses 1 divided by 4, and we're going to hit enter. Now I'm taking mine out to 4 decimal places, okay? And that's what I got, okay, as my base. I went to 4 decimal places because if I go to 4 or 5 decimal places, I'm less likely to introduce that much error, okay? But it does show that it's decaying. because my base is less than 1, right? So what we have to do now, here's my base. Now I need the initial value, right? Well, it was what? 32,000, 0.8409 raised to the t. Now this t is going to be time since 2009, because I'm going to say, hey, t equals 0 at 2009, right? So instead of putting 2018, 2013, I'm going to say how long has it been since 2009, right? So what I'm going to do will be 32,000, 0.8409 raised to the, we want to know what it's going to be worth in 2018, right? So 2018 minus 2009 comes out to be 9 years. Would y'all agree? Okay, so you take 0.8409, raise it to the 9, and then times it by 32,000. And ladies and gentlemen, we have 67, 27, 17. So that's what the car is valued in 2018. And it said round to the nearest dollar, so that would be 67.27, right? Okay. Now hang on to this equation, because this equation right here, this little technique is not taught a lot. Okay. Um, so I use it because, you know, if they give me 2 data points, which is really what they're giving me, right? It's like in 2009, it's 32,000, and in 2013, it's 16,000. You can write the equation from 2 ordered pairs, right? Um, but I think this right here is a much easier approach to doing it when you're having a word problem. Okay. The new value over the old raised to the 1 over how long did it take to go from the old to the new, and that would give me my base. Okay. So I don't want to cut y'all short, but um, I've got a help session at 7, and uh, tomorrow we have one at 5 o'clock. I don't know if you can attend, but I put it at 5 o'clock. Uh, it's, it's y'all. I'm giving you 3 help sessions a week: Monday, Wednesday night, and then a Thursday night at 5. Just to give you another opportunity to kind of work problems that you worked on Monday and Wednesday, and then have a last opportunity to get some questions answered. Fair enough? So, yes, ma'am. Now it opens on Thursday, right? And it closes on Sunday.